Now it should be pulling up a simple document that talks about something called degrees, minutes, seconds. Degrees, minutes, seconds. If you feel like you want to write something down as you go through it, feel free to just make it a little carve out in your notes and then see if you can do the problem that's on the screen. Again, if you're jotting down maybe something in your notes, maybe give it a little label so that you can refer back to this if you feel like you're going to need to. Degrees, minutes, seconds. And then see if you can get this problem that's on the screen, 64 degrees, 32 minutes, 47 seconds. All right, now I asked you to do something that basically is asking you to try to read something, interpret it. That can be hard to do. Maybe you're like, I'm not completely sure. I'll try it. Sometimes it's helpful to hear it another way, straight from the teacher's mouth. Although I wrote that for you, sometimes students, when I say this, like, oh, that's all it is? Because really, it's always out of an hour. It's always how much is in an hour, how many minutes are in an hour, how many seconds are in an hour. So each of these decimals is out of an hour. So there's 32 minutes out of 60, 32 out of 60 minutes in an hour. Okay, 32 out of 60, that's like just about a half. In fact, it's a little more than a half. So right now we have 64 degrees and about another half degree. And then we get into some more precision because now we're into seconds. And again, it's out of an hour. How many seconds are in an hour? It's always going to be that number, 3,600. So it turns out that all you really need to do is just add each of those decimals. And you can do that in one step. Again, it can be this easy. It's just 64 plus 32 out of 60 plus 47 out of 3,600. A lot of times students say, well, why? And that's where I gave you some of that information, that it's really based on circles. And it's just a different way to measure. You see this a little bit more in some applications. You will see it pop up in a few application problems. It's just another way to measure or describe a decimal of an angle. Again, if you jotted something down, or if you want to, you can even say to yourself, it's always out of an hour. So it's 60 minutes and 3,600 seconds. The main thing I want you to realize, if you see this notation, degrees, minutes, seconds, if you see that notation, that you're able to convert it. You always convert it. Now, there is actually I guess it's a function that's on your calculator. I think it's in the angle menu. Now, if you have a scientific calculator, I think it's also in there somewhere, but just a little bit of extra here. It's called DMS, degrees, minutes, seconds. And what it does is it will take a decimal and it'll turn it back into degrees, minutes, seconds. I went to the angle menu. You'd have to find it. And then I searched out DMS. There's never a time that you have to use that in class. That's just a little extra information. It only works if the decimal was perfect to change it back into 32 minutes, 47 seconds. Is there anything else to add to that, or something to clarify? Are you sure? Okay, save that page or that little tiny URL if you want to, in case you need to refer back. How about the homework? Kind of curious, when you got to the last couple problems, like 38B. 38B, did you keep adding until you got something positive? So like the answer to 38B, well, the positive answer could be 340. Now, do you realize the negative answer could be just negative 20? But there's many negative answers. You can actually do 38B without, did I not assign that? No, everybody's looking at me funny. I should have assigned 30. All right, so hey, 36B, did you keep adding until you got something positive? So, you have to add 360 twice to get yourself to 330. And then your negative answer could be just the negative 30 that you would get by adding, or you could subtract and be more negative. Okay, so you can add 360 as much as you need to. Is there any questions with 36? and I did not assign 38. All right, I want to talk to you about another kind of angle today. We can, well, I'll call this intro topic Now, yesterday, I just wrote the word angles. If you want to change your notes, you could write the word coterminal angles. Again, you could add coterminal to yesterday's. But today, I want to talk to you about something called reference angles. And so, definitely give that little heading. Now, this time, I'm just going to give you the definition, and we'll process it so it's a little bit more of an analysis where we're taking something and we're kind of breaking it apart. Yesterday, I kind of made you put it together. So this time, let me give you the definition of something called a reference angle. And then we'll kind of do an analysis on this. We'll sort of break it apart. Now, as you write down the definition, which I think would be a great idea, think about it. What are some things that you see up here? So what do you think about some of the sort of key words in this simple little definition? Actually, before we get to the words, maybe a symbol. Okay, many times mathematics uses symbols, and I want to make sure you realize what you're talking about. That's a prime sign. We would say theta prime, maybe like in your physics class or other applications. If you see prime, there's usually some connection back to an original. So in this case, the connection is that I'm going to give you theta, but you're going to find theta prime. You're going to find its reference. You'll see. But prime just means that it relates back to an original theta. Now, acute, okay, kind of common word from geometry. Make sure, though, that you're processing that. Remember, less than 90. But greater than 0, technically greater than or equal to 0. But the main thing here is that we're looking at an angle that's between 0 and 90. That'll be important. How about a terminal side? Should be something from yesterday that you realize is the rotating part. Now, I know we all know what the x-axis is, but it turns out that that becomes maybe the most important part. Now, if I give you a theta, I wonder if you could find theta prime. If I give you an angle, could you find its reference? So how about theta equals 240? Could we find theta prime? Okay, a problem like this almost says to you, sketch me, make a sketch. Make a sketch so you can see the terminal side. Make a sketch so you can see the x-axis. Okay, now, of course, when we make the sketch, you're going to make it in standard form. Now, what I hope that you're doing here is seeing if you can go to the next step. Like, see if you can process this definition. Do you see an acute angle? Do you see it with the terminal side in the x-axis? And so, what would be the reference? I know this is the first time you've done this, which it's fine. Let me kind of walk you through here, because if you highlight the terminal side, either you physically highlight it or you just kind of focus on it, kind of makes it stand out. If you highlight the x-axis, then you start to see this thing called a reference angle. All we got to do is determine how big it is. Now, the reference angle would be this space. Technically, it's an angle, so it'd be this angle. Again, all we have to do is determine how big it is. How'd you get 60, Liam?
I just took 180. So I subtracted 180.
And is 60 an acute angle? Certainly. So it's your reference angle. Question: why would this space or this angle not be the reference angle? Why would this orange angle not be the reference? Anna? Okay, now at this point, we just kind of follow the rules, but you guys will learn why it has to be the x-axis soon enough. But right, it's got to be the x. Now that's a common mistake, because sometimes kids see that as the open space. Nobody said it's like the open space. Like Anna said, it's the x-axis. Okay. How about seven pi over 4? Theta equals 7 pi over 4. And we want to find theta prime. Now I know I did it. I gave you a radian angle. Welcome to the club. We're going to use radians. We're going to use degrees. So what will you do with 7 pi over 4? You still have to locate it. You still have to sketch it. Just so you're aware, some students are converting this. That's fine. If you're converting it, that's fine. Maybe that helps you to understand 7 pi over 4. For those that are converting it to degrees, just know that your final answer, because of the math etiquette book, says that you need to put it back to radians. So because the problem started in radians, my answer is in radians. If you did not convert it, you just kind of worked with it, you don't need to switch back, but you want your answer in radians. Looks really good. You guys are doing a good job. I'm just letting you kind of work it out. Now you're doing it, but I just want to highlight it because it's good. You're interpreting the x-axis, and you're doing it really well. You say, what do you mean I'm interpreting it? Well, what x-axis, in other words, what angle do we think of the x-axis for this? You didn't think of it as 180, right, Grace? And some of your classmates use 360. Again, good. Okay, you're thinking of the x-axis, and that's the way this works. You just kind of adapt depending on the quadrant. It's probably not a big surprise that depending on where we end up is how we think of the x-axis. Now, did you really use 2 pi? Like, how did you subtract? Did you really subtract with 2 pi?
No, I used 8 pi before.
Oh, okay. That's still 8. That's still 2 pi. How did you subtract? So basically, what's the setup?
Well, 8 pi over 4 minus 7 pi over 4.
And
pi over 4.
Good. Now, I wanted people to see that you can subtract with 2 pi. Like, you can actually do it in radians. Okay? But you can also do it in degrees. As some of you did, you subtracted with 360. You just want to make sure that you turn it back into pi over 4. The main thing here is that you have an angle that goes with the terminal side and the x-axis. We call it the reference angle. Let me give you another one. And each one of these is kind of progressively forcing you to think about how to adapt. So here I have theta equals negative 200. Theta equals negative 200 degrees. In general, it looks really good. You guys are taking, well, a negative angle. You're trying to adapt it to this definition. Make sure, though, that every part of the definition is true. For some of you, you just want to take a second look at what it means to be acute. Like, technically, what does it mean to be acute? Okay, so make sure it fits every part of the definition. So sometimes the question boils down to, is the answer positive or negative 20? Is it positive or negative 20? Well, if it's negative 20, then it's not acute. If it's negative 20, it doesn't officially fit the definition. Okay, so you want your answer to be positive. Now, I'm kind of curious, like, how much did you think about this? In other words, how did you actually end up with 20? Like, how did you actually subtract? Sometimes kids will subtract with the negative, like literally negative 180. Okay, now sometimes kids don't do that, but if you subtract with the negative, it will work. You just have to make sure that you get the double negative. So negative 200. I just did that backwards. See, I have to be careful too. So if you subtract negative 200, it'll allow you to actually end up with positive 20. Now, if you're saying, I didn't really do that, I just kind of subtracted it and I got negative 20, that's fine. If you just kind of subtracted it and sort of got negative 20, all you have to do is say, but it's not supposed to be negative. Just make it positive. Okay? And if you kind of thought of these as absolute numbers, like absolute 1 or absolute 200 minus absolute 180, well, that works also. I don't want to make a big deal out of it, except to say that as long as you find the difference between the numbers, that's your reference. And it has to be positive. Now I'm going to give you like a little exit ticket. Exit ticket's something to ask you to do before you walk out of here. Usually it takes what we did and maybe extends it a little bit. But it's 2 questions that will use this idea of reference. I'm going to have you just put on a piece of little scrap paper here. When we do exit tickets, it's not a quiz. Okay, what that means is you can discuss. Okay, you straight out can discuss. You never should copy off of someone, but you can change your answer. You can discuss it and learn from it. So just know that that's okay. Most of the time, kids will try to do as much as they can on their own and then maybe do a little bit of comparing. So it's not a quiz, but it is something you want to try to get correct. You show whatever work is necessary. You should have more than just an answer, but your work might vary. You might have a sketch, you might have some numbers, but you should have some work to support what you did.